Hello everyone, welcome to Irash Academy. In this chapter we are going to talk about subnetting on class A network. And before we start this subject, let me explain what is the subnetting is. Subnetting is the process of dividing one network into the multiple subnetwork. And why do we need to do that thing? This is to save the IP address and for more efficient network management and IP address management. That is the benefit of subnetting. So I have made two more videos earlier that describe about the class B network subnetting and class C network subnetting. If you didn't watch those videos, watch it before you continue with this video. Because when you watch that video, you will understand the concept in a simple way. Then you can come back to this video. I have marked those videos under the card section of this video, so you can easily find it out. I hope you understood the concept of subnetting. But where to use the subnetting? Where I can use the subnetting process in real life scenario? For that, I explain you an example of Irash Restaurant Group. So, welcome to the Irash Restaurant Group. This is a restaurant group. It is initially started their business at New York City. Initially, they had 5 branches and at that time, a class C network was enough to provide the IP address to all the branches. Then later on, Irash Restaurant Group expanded their business into multiple area of United States of America. As you can see, they expanded their business to New York City, Los Angeles, Chicago, Philadelphia, Dallas, and each area there are around 10 branches. So one single class C network was not enough to provide the IP address to all of those branches. So they redesigned their network from a class C network into a class B network. So they were able to provide the IP address to all branches as per their requirement. And now the situation has been changed. Irash Restaurant Group is growing now and they are expanding their business to all over the world. Initially they were focused on USA, but now they are expanding their branches to India, Russia, UK and Africa. And each country they have around 200 branches. So in this situation, the previous class B network, it is not enough to provide the IP address to all these branches. Because as you can see, they have around 1000 branches now. So each branch need a separate network. That means they need 1000 network. So in this situation, their network architect team decided to redesign their network. And as part of this redesign, they brought a class A network instead of class B network. The class A network has a very wide range of IP address. It would be enough to provide IP address to all of their branches. But there is only a single class A network, that is 10.0.0.0. And they need to use this IP address to all of their 1000 network. So basically it is not possible in the first site because they have only one class A network and that need to distribute around 1000 network. That is not going to work. So to make it work, you can do the subnetting. So what is the subnetting process? The subnetting means this single class A network, they can divide into multiple subnetwork. Let's say they can divide into 1000 network as per the requirement. Then each network they can assign to each branches all over the world. And by doing that, they can provide enough IP address to all the branches to connect their computer, printers, cash machine, CCTV camera, wireless access point, anything they want. So here when you see the IP address, there is a single class A network IP which is 10.0.0.0 and it is going to divide into multiple subnetwork so that everybody can use their own network. So this is the process of subnetting. This is the beauty of subnetting. By doing this thing, they can do a better network management, better IP address management. They can save a lot of IPs. There is no IPs going to waste by doing this thing. So this is the simple concept of subnetting. So in this video, we will see how to perform subnetting based on the network requirement on class A network. Let's begin. Welcome everyone to this video. Welcome to CCNA 200-301, Implementing and Administering Cisco Solutions. Chapter number 57, Subnetting on Class A Network Based on Network Requirements. Learn CCNA with Irash Academy. I have placed the complete CCNA playlist at the top right corner of the video information bar. So as like my previous videos on subnetting, I am going to give you a summary about the basic requirement that needed to do the subnetting. So the point number 1, you need to understand the basic IP addressing, such as what is IP address, what is subnet mask, and what is default gateway. Point number 2, you need to understand the classes of IP address such as class A, class B, class C, class D and class E IP address. And the third one, you need to know the numbering conversion. And what is the numbering conversion? That is binary to decimal conversion and decimal to binary conversion. And the fourth one, you need to know how to subnet class C IP address. And why do you need to know the class C subnetting process before? Because it is very simple to understand, and when you get the concept by doing it on class C, then you can do on class B and class A better. So that's why I mentioned first you need to learn how to do the subnetting on class C IP address, then easily you can do it class B and class A. And there are 3 steps that you need to follow when you do the subnetting process. And point number 1, convert the number of networks into binary and find out how many bits required for that. Point number 2, reserve bits value in the subnet mask and find your increment. And third one, use your increment to generate the network ranges. So I will explain all these 3 points and I will show you how to do a subnetting on a class A IP address. Let's begin. So let's go with the point number 1. Convert the number of networks into binary. And in this point, you need to understand what is the total number of network required. Then you need to convert the number into binary. So here, what is the total number of network required? Let me take you back to the network diagram and let's see what is the total number of network requirement. So the proposed network diagram you can see in the screen, and here the Irish restaurant group has branches at USA, India, Russia, UK and Africa, 5 countries, and each country they have 200 branches. So how many total network they required? It is 1000, right? So you got the number 1000 as the total number of network requirement. Now let's go back to the subnetting process. So the total number of network requirement is 1000. Okay, now convert the number into binary. So we need to convert this number into binary. So how to convert this into binary? For that, we need to take the support from the binary to decimal conversion table. So let me take the binary to decimal conversion table into the screen. Here we go. So here we need to convert this decimal number 1000 into binary. Now the question is, what are the numbers from this binary conversion table you need to add to get the value 1000? In this table you can see 128 is there, 64 is there, 32, 16, 8, 4, 2 and 1. The answer is, even you add all this number together, you are not going to get the 1000, because by using 8 bits you can get maximum number of 255. That means when you add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 and plus 1, you get maximum 255 value. So in this situation, how you are going to convert this 1000 into binary? It's not possible. So what you need to do for this conversion? So to do this conversion, you need to increase the number of bit. For example, here by using 8 bit, the maximum value you get is 255. That is not enough. So add more bits into the table so that you can reach a value of 1000. For that, let me increase the number of bits into 11 bits. Now let's see if we can get the result of 1000. Okay, now we'll consider the first value. It is 1024. When you consider the 1024 itself, it is more than 1000. So we cannot take it. So I will mark it as a 0. Now take the 512. Okay, that we can take because it is less than 1000. Now there is a 256. That also you can take because it is less than 1000. Now there is a 128. That also you can take it. Now let me see how much we need more. First we'll go to 1000. This is our requirement. Then 512 came. 1000 minus 512 is coming 488. Okay. Then 488 minus 256. It is coming 232. Then 232 minus 128. It is coming 104. So next one is 64. So we will take 64 because what we need is 104. So we need more number to add. So we'll take 64. So now 104 minus 64, what is coming? It's coming 40. Now 32 we can take. So 40 minus 32 is equal to 8. And 16 we cannot take because we need only 8. 8 we can take. Okay. So 8 minus 8, then it is equal to 0. All the values completed. Now remaining we can take 0, 0, 0. So the binary equivalent number for the value of 1000 is 1, 111010000. So this is the answer. When we convert the decimal value 1000, we get this value as binary. Now go to the next step. Reserve bits in the subnet mask and find your increment. And here you need to find out what is the subnet mask. Then you need to convert the subnet mask into binary. So what is our subnet mask here? We know the network 10.0.0.0/8 is our network, and it is a class A network. So what is the subnet mask of class A network? It is 255.0.0.0. This is the subnet mask. Now we need to convert the subnet mask into binary. So 255, how we can convert it to binary? 255 stands for 11111111. All the 8 bits are 1. Then dot 0. 0 stands for all 0. 80. Then again the third octet 80. 1 2 3 4 5 6 7 8. Then again last octet 0, that is 1 2 3 4 5 6 7 8. Okay. So here the 1 indicate the network part and the 0 indicate the host part. So by default in the class A network, the first octet, that is 255, this one, it indicate the network part, and remaining all the 0 indicate the host part. Now what is our requirement? Our requirement is convert this single class A IP address into multiple subnetwork. For that, you need to sacrifice some of the value from your host part and convert into the network part, because we need 1000 network. To get that 1000 network, we need to sacrifice some value from the host, then give that to the network part. So how many host portion I need to sacrifice? To know that thing, you need to first understand how many bits you require to get the decimal value of 1000. That means to get the number of 1000 network, how many bits value you need. So here, this is the 1000. And to get 1000, I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bits value is required to get the decimal value 1000. So here what I need? 1000 network. So I need to exactly sacrifice 10 bits from my host portion into the network portion. So here, which one is the network portion and which one is the host portion? This is the network portion, and right side wherever the 0 show, it is the host portion. So from here, I need to sacrifice 10 bits and convert into network side. So here 10 bits, let's calculate from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this will be your new boundary where the network and host separation is happening. So let's convert the host portion into network part. So here the first network part remain as it is, 8 ones. Okay. Then this full octet I am going to convert into network part. Again 8 ones. Then in the next octet, the first 2 0 it need to convert into network part. So first 0 I make it as 1. Then remaining all are 0. So 0 0 0 0 0 0. Then last octet all 0 0 0 0 0 0 0 0 0. So this is the new subnet mask that you need to use in your subnetwork. Now let's convert this new subnet mask into decimal. So here our answer is, the first part is all 1, so 255. The second part is all 1, that is also 255. Third part, the first 2 bits are 1. So here when you distribute that 1 here in 128 and 64, because this is the 8 bit only, if you calculate from here 1 2 3 4 5 6 7 8. Okay, so the first 2, that means 128 64 is 1, remaining all are 0. So just add this 128 and 64 together, then you get 192. Then the last octet is all 0, so that is 0. So your new subnet mask is 255.255.192.0. This is the subnet mask you need to use in the subnetwork. Now let's go to the point number 3. Use your increment to generate the network ranges. And for that, you need to find out the increment value for the network. So how to find out the increment value? To find out the increment value, you need to closely look into your new subnet. And what is your new subnet? That is 255.255.192.0. This is your new subnet. And you need to closely look into the binary section of your subnet mask. So which one is the binary section? This one is the binary section. Okay. This is the binary section of my subnet mask. Here, To find out the increment value, find out the point that separate the network part and the host part. As you know, the 1 indicate the network part and the 0 indicate the host part. So to find out the increment, you need to consider the least value of your network part. That means this one. This is the least value. Okay, remaining all are host part 0. I cannot take it. I need to consider the least value from the network side. Then you need to find out the position value of this binary. So this is the 8-bit in the third octet. So I need to find out what is the position value of this number 1. To understand that, I can distribute this number into binary conversion table. So it is like 1 1 0 0 0 0 0 0. And here this is my increment value, same like this one. And what is the value indicate the increment value? It is 64. So our answer is increment value is 64. This is our increment value. So we need to use this increment value to generate the subnetworks. So here we got our answer, subnet mask and network increment value. So what is our subnet mask? It is 255.255.192.0. And what is the network increment value we received? It is 64. Okay. Now what is the next step? The next step is generate the network. And how to generate the network? I will show you. So first of all, what is our network? Our network is 10.0.0.0. This is our network. Okay. Now we need to add this increment value 64 to generate our new network. And where to add the 64? If you look at the subnet mask, you can see the least network point, this octet. Here we need to add the increment value. So let's add the 64 and generate the network. So the next network will be 10.0. This is the third octet. 0 plus 64 is 64.0. Then 10.0.64 plus 64 128.0. Then the next network is 10.0.128 plus 64 192.0. So what we got here, the starting IP address of each network. Now how to find out the ending IP address of each network? We need to find the ending IP address. How to find out that thing? The ending IP address is the previous IP address of the next starting IP address. So which one is the next starting IP address? 10.0.64.0. This is the next starting IP address. So we need to reduce one IP address from this, then we will get the ending IP address of the previous network. So here let me show you. Here it is 10.0.64.0. So what would be the previous IP address? That is 10.0.63.255, right? After 63.255, the next IP address is coming as 64.0. So next one is 10.0.128.0. So what would be the ending IP address of the second network? It is 10.0.128 here. So when we reduce 1 from there, it is 127. Then here it is 0. So previous one is 255. Okay. Then the third one is 10.0.191.255. Correct. So in this way we can find out the ending IP address of the each network. Now let's go back to the next network, that is 10.0.192.0. So to get its ending IP address, first we need to find out what is the starting IP address of the next network. So we need to add the 64 into that. So next one is 10.0.192 plus 64 is coming as 256.0. Okay. Did you see anything wrong here in this network? If yes, where is the error? Did you see this 256? Is there any possibility to get the value 256 in an IP address? No. Maximum we can get 255 only, because the IP address each octet contain 8 bits. When you add all the value of 8 bits together, then we get decimal value of 255 at maximum level. So there is no point that you can get a 256 at an IP address. But We did everything properly, right? We added the increment value 64 into the 192, and as per the mathematics, we get the 256. So how it can be a mistake? There is no mistake in that thing. Let me show you. Find out what is the ending IP address of the previous network. This 10.0.192.0, find out its ending IP address. To find out its ending IP address, find out what is the previous IP address of the next network value we got. So that is 10.0.256 is here. But when we do a -1, we get 255. Then 0 here. So the previous one is 255. Did you see here? The ending IP address of the fourth network is 10.0.255.255. Is it a valid IP address? Yes, this is a valid IP address because we can see maximum 255 only here. Then what would be the starting IP address of the next network? Is it this one, 256? No. It's wrong. So what would be the actual starting IP address? So let's see what is the next IP address coming after this. Here third octet is 255, fourth octet is 255, that reached the maximum value. So where would be the next value start? Next value will start in the second octet, this one. Here it is 0. So the next one will be here 1. So this is wrong. This is not a valid network. We will get the actual network as 10 dot. This 0 will go to 1. Okay. Then after 255 and 255 we get 0.0. Exactly, this is the next IP address. Now you need to add 64 again to get the next network. And where you will add now? In the third octet again. So the next network will be 10.1.0 plus 64, 64, then 0. Next one will be 10.1.128 because 64 plus 64.0. So in this way, calculate the ending IP address of the previous network. Here it will be 10.1.63.255. Then here 10.1.127.255. So in this way you need to generate 1000 network. This is the concept. I hope you understand the concept. I hope you understand how to use the increment value to generate the network. And finally you get all of your 1000 network as shown in the picture. Here I have limitation to display all the 1000 network, so I just provided a sample. So in this way you can do subnetting on a class A network. So in this chapter you have learned how to do subnetting based on the number of network requirement on class A network. Thank you very much for watching and subscribe to the channel for more videos. Enhance your skills using Irash Academy.